Hey Internet, welcome to Heat Transfer Tutorial. This is a made-up question not found in your textbooks. We got a hot water cylinder at 61 gallons. The initial temperature is 51 degrees Fahrenheit. The final temperature is 120 degrees Fahrenheit. We want to find the heat transfer with BTU units, so British thermo units. The average temperature is 85 degrees Fahrenheit. Step 1, draw your free body diagram, your FBD. This will help you visualize the problem. So hot water cylinder, 61 gallons, initial temperature, final temperature, average temperature. Okay. Step 2, list all the given variables, find the unknown. We're trying to find heat transfer, which is Q. And here's all the temperatures, here's the volume. We also know it's water. Step 3, find the heat transfer formula. Q is equal to mCp delta T. M is mass, Cp is the specific heat capacity. Delta T is the change in temperature. What we're going to do is expand mass. They don't give us mass directly, so we need to figure it out. So they give us volume. We can work out the density because they give us the substance. And then the temperatures, they are given in the question. Step 4, find the mass formula. So it is M, which is mass, is equal to density, which is the Greek symbol rho, multiplied by V, which is volume. Note that V, in this case, is equal to volume. Do not confuse with mass flow rate, which is m dot, which is equal to density multiplied by velocity multiplied by area. So little v is velocity, big V is volume. Students get this confused quite often, so I made a note here. Okay, what we're going to do is find the density, and then we're just going to plug it in as is, just so we can eliminate rounding errors, because next step we're going to find density and you'll realize why that's going to be an issue with rounding errors. So step 5, find the density of water at 85 degrees Fahrenheit. So that's the average temperature. Alright, so you've got two options. You can use Google search or you can look it up in your table. So I can't show you the actual table, but we're just gonna use this mini table. This will be good enough. So at 80 degrees Fahrenheit, we've got this density, 62.22. At 90, we've got 62.12. The problem arises when we hit 85. So in your lookup table, they go in increments of 10, not in 5s. So what does that mean? Well, we need to linear interpolate. So here is the general formula for the ratio method of linear interpolation. This will be your first introduction to linear interpolation for heat transfer. Okay, so we've got max A minus min B divided by max A minus the given is equal to max A2. So the A2 represents the maximum, but on the right hand side. So, and that's the same for min B2 divided by what we're trying to find minus min B2. So the crucial thing is know that max represents maximum, which is 90, and then the A2 represents the max on the right hand side, which is the density, which is what we're trying to find. So we've got 90 minus 80, so that's max minus min, and then max minus the given, which is 85. And then we've got 62.12. So that correlates with the right hand side of the maximum. And then minus 62.22, which is the minimum on the right hand side. So don't panic and don't get confused. The number may be smaller sometimes, but you need to relate the number exactly with the maximum and exactly with the minimum. Don't get confused and think that this number is bigger, then that must be the maximum. No. So have the maximum with the maximum density and the minimum with the minimum density. I hope that makes sense. And then have your unknown, which is your density at 85. Okay. So you plug this into your graphic calculator solver, and then you will find you'll get 62.17 pound mass per foot cubed. If this number is in between these two numbers, you know you linear interpolated correctly. If the number is outside of the range, then you've done something wrong. Step 6, we want to find the specific heat capacity. Once again, this is just a table that I've grabbed. It's not the full table, and it's a custom table basically. Both of these tables is custom made. So as you know, these questions are made up for copyright reasons. Okay, so the range for CP, as you can see, 80 to 90 is 0.999. In fact, the CP doesn't change for quite a while. It changes when it's at 50 and in the hundreds, I think. So it's quite a big range that stays pretty much the same, which is great. So we're just going to take 0.999 as our CP. Step 7, we can now backtrack and find the heat transfer. So we're just going to plug and play the density that we found as 62.17. The volume is given as 61 gallons. Note that we need to convert gallons to foot cube to cancel out the units. And then the difference in temperature that is given in the question as well. So once all your units cancel out, you will get 35,490.09 British thermo units, BTU. That is the amount of heat transfer required to go from 51 to 121. So calculate the amount of energy required to heat the water to this maximum temperature. Yes. Okay, so disclaimers. The method is correct. However, I do make calculation mistakes. I encourage you to solve it yourself, especially with the linear interpolation part. Okay, so before we leave, I highly encourage you to save this video onto your PC just in case this video or channel gets taken down while I follow all copyright laws. Sometimes things happen. You can do this by using snipping tool. If you're on a Mac, use the Mac equivalent of snipping tool. If you never used snipping tool before, follow these instructions. Click on the icon in your taskbar. If it's not on your taskbar, go to your Windows search, type in snipping tool, open up the program. click on video option, click on new, left click and drag the rectangle to cover the YouTube screen. This is just an example. Hit the start button and snipping tool, wait for the countdown. Hit the replay button on YouTube, let the video finish, hit the red square and snipping tool to stop recording, then save your video. Thanks for watching. Hope you had a great day. Be sure to like and subscribe. Share with your friends because this is a made up question, so they probably won't be able to find it. If you got questions, comments, or if you find a mistake in this video, leave it in the comment section. I will get back to you as soon as possible. If you want to support me, become a member or drop a super thanks. Until next time, see ya.